Alrighty guys, we're here for day 5, okay, of graphing sine and cosine. Worksheet 6-6B, I posted a blank copy to Schoology, as well as my notes from this. I will be posting that, and there will also be an answer key. Your homework is to finish this. So you should see on the second page here, we start our homework section. I will post this so you can check your answers. But let's get started on finding the equation of these guys. So the first thing you want to do, all right, is sketch the boundary lines for these. Okay, so it's kind of what we've always been doing when we graph, all right? Then since this is, up 1 and down 1, this is a total of the distance between these two is 2. So if I want the middle of this, I divide it by 2, and that gives me, right, a midline at 0, right, because there's one above and one below. So this is my midline along the x-axis, which is y equals 0, okay? So we haven't shifted it up or down. So that means D is 0, and our amplitude is just 1, because that's the distance from our midline to our maximum, or our midline to our minimum, right? So you're going to want to think about minimums and maximums here, and hitting the midline as well, because that's usually how we graph, all right? So we have A and D, all right? Then the next thing you want to do is, since I haven't done so, it kind of depends on where you're thinking about starting your graph, okay? So if I look here, this is point A, okay? Let's just say that's point A. I just picked a point. Again, usually you're going to pick one along the midline or a min or a max, okay? So if I choose A, that means I'm going to be dealing with sine, right? Because we're starting at the midline. All right, so I'm going to use the sine function to write this, all right? So, and remember, the sine function usually looks like this, doesn't it? Which is exactly what our graph looks like, okay? So you also want to think about, so we have A and D, then we have to find B and C. Now, C is usually pretty easy to see. That's a phase shift, okay? Now, since our sine function starts, right, at 0 radians, which is where the parent function usually starts, that means we have no phase shift, because this is the normal sine function starting at 0 radians. So therefore, C is 0, right, or C equals 0, okay, or there is no C. You don't have to show it. So you want to consider the phase shift. Then the last and final thing is the B value. So to find the B value, what you have to do is find the period of this function. So this is a sine function. So a full sine curve starts at 0, goes up, hits a max, comes back down, right, hits our min, and then comes back to our midline, all right? So if we look here, if I hit the max, right, I come back down, I hit the min, and then the next time I hit the midline is here. That is a full sine curve, okay? So this full sine curve starts at 0 and ends at 3 pi, sorry, I'm not reading that right, 4 pi over 8, which is really, if I reduce this, pi over 2, isn't it? Okay, they just didn't reduce, just didn't label this. Now the way I knew that is I saw this was 1 pi over 8. This would have to be 2 pi over 8, right? Because our scale should be consistent to then get me 3 pi over 8. Therefore, this is 4 pi over 8. So they may not label every single point on your axes. You should be doing that. Some of you are not on your homework, so be aware of that. But our period is 0. We see a full curve from 0 to 2 pi. So that means my period is pi over 2, okay? So now, kind of working backwards, we need to find the B value that gave us that period. So to find B, what we're going to do is go 2 pi divided by B gives us pi over 2. And then since this is proportions, right, we're going to cross multiply. So we get 4 pi equals B pi. If we divide by pi, the pi's cancel, so B is 4, okay? So far we have D, A, and C. And then we just found b, so that means we have every single number we need for this. So if I'm drawing, or writing the equation, I should say, from the point A, we would have 1 times the sine, right, of b, which is 4, right? And then we have theta or x, it doesn't matter which one you do. Our c is 0, so we're minusing 0. And then our d is plus 0. So really, this is simplified to just y equals sine 4 times theta, okay? You may see it written like this. They mean the same thing, okay? The 4 is just factored out here. It's included. You should always write it in factored form if there is a phase shift, but since there's no phase shift, either one of these are fine, okay? Now, the nice part about this is A, D, and B all stay the same when you go to write this from maybe a slightly different perspective, right? So if I think about, like, let's say you're looking at this differently than another classmate and you start at point B, okay? So if I look at this from point B, because all these points are on this graph, and because of the sinusoidal or the periodic, because it's a periodic function, this could also be a cosine curve if you consider the graph starting here, which is weird, I know. But if we start here, then that means we haven't changed, right? If I were to draw my boundary lines and my midline, those would not move. So therefore, A and D are the same values, okay? I also, if you look at cosine, the cosine curve, right, looks like starts high, right? Our maximum is kind of like a valley. We hit the minimum and then we come back up by the time we get to 2 pi. That curve happens from pi over 8, 1 pi over 8, and if I dip down, hit my min and come back up, and I hit the next max, that's a full cosine curve, isn't it? So that happens from 1 pi over 8 to 5 pi over 8. If I find the difference of those two, isn't that really just 4 pi over 8, which is the same period? So the period is going to remain the same as well, because we're not stretching or shrinking this curve at all. We're just changing where we're starting. So the only thing that will happen if you look at it from a different perspective, sine versus cosine, is you will now have a phase shift, okay? So if I go to point B, I'm going to use a cosine curve, right, because we start high. So this is going to be cosine, because we start at a max, not the midline, okay? So if I'm starting here, my amplitude is going to be the same, so I'm going to use the same A. My D is going to be the same, right? My B, because I haven't stretched or shrank this, is going to be exactly the same. I'm just going to change my to cosine. And then I'm going to write this in factored form because now I'm going to have a phase shift. So if you look here, right, usually for cosine, right, at 0 radians we start high, but now I've moved that over and started my curve slightly to the right. I've moved over pi over 8, so that means I've shifted, okay, it's called a phase shift to the right. Now, every time I shift left or right, it's always the opposite, okay? So phase shift for C, it's always the opposite, okay? So I'm just using A, B, C, and D. This one is going to be, since I'm going to the right, I'm going to actually subtract pi over 8 because we're shifting to the right. It's always the opposite. That is my cosine function. Oops, sorry about that. You can simplify it like this. Leave it in factored form. Do not distribute. You're fine, okay? I mean, if you did distribute, it would just be 4 pi, right? So I'm totally fine with you leaving it like this, okay? This one, either one of these. Sometimes in other books, they might distribute it. Just be aware. It would look like cosine 4 theta minus, and then if we do this, this is pi over 2. So if you distribute the 4, these two are equivalent functions. I would just leave it in the factored form, okay? Now, if we look at the next guy, okay, the next one, if I start at A, let's say, okay? And again, now I'm picking at the 0 radians part. This happens to be a maximum. So right now I'm thinking this is gonna be cosine, because I'm starting at a max. So if I start cosine here, right, let's draw our boundary lines in. Okay, regardless of which point I use, these will always be my boundary lines. That's my maximum, this is my minimum, right? So in the middle, down the middle of this, if this is 0 to 2, right, that's a difference of 2, half of that is 1 and 1. So I'm going to draw a line, a distance of 1 from the upper boundary and a distance of 1 from the lower. That's my midline. So my midline is y equals 1. So that tells me D is 1. And my amplitude, right, this is 1, up 1, down 1. So my A is 1 as well. Okay? So A and D are the first things you should always find. Then we pick our point like we did, A. That's a maximum, so we're going to use cosine, okay? Now, if we look, is there a phase shift? Well, no. We have our basic cosine function where we start at the max at 0, so there is no phase shift, okay, for this. No phase shift. Then I take a look at my period. Well, if I start at a max here, I hit my valley, my low, minimum, and I come back, that is a full cosine curve. So that happens from 0 to 4 pi, doesn't it? So that means my period is 4 pi. So therefore, to find B, we're going to do 2 pi divided by B equals 4 pi. Cross multiply. So I get 2 pi equals 4 pi B. Divide by 4 pi. And then therefore B is 1/2. So there's no phase shift, sorry, jumping back to this. So C is just 0. So now I have A, B, C, and D. So I can write my equation. So from the A point, y equals, right, 1. This is cosine. Okay, our coefficient to theta or x, we could just use x too. There is no phase shift, so that's just x. And then my D value, right, I shifted everything up, plus 1. Okay, now for sine, right, we can also think of it as starting here. Oops, sorry. At our midline, okay? So another acceptable answer here would be y equals 1 sine, right? My B value stays the same, so remember A, B, and C are always, I should say A, B, and D are always the same. Now I want to think to myself, well, if this is B, right, and this is sine, did I shift this? Well, it starts, right, here. So my sine curve, remember back up here, usually goes like this, right? So if I start at 0, now I'm starting at what? Well, this is 0. That's 2 pi. This is exactly half. So this has to be pi, 2 pi. This would be 3 pi, which makes sense with our 4 pi. So that means I've shifted to the right pi. So I'm going to subtract pi there, okay? Now, what you also want to think about is this started here and then it went down. Sine usually goes up. So that means we reflected over our midline, right? So that means this has to be a -1 sine, okay? Or just negative sine. Okay, so this has a reflection in it as at the end. So just be careful of reflection. Okay, maybe you want to make yourself a note at the beginning, okay? Last but not least, right, we have this guy. So let's say I start here first, okay? No, actually, do it this way. I'll start here first. So I'm starting high, which makes me think this is cosine, okay? I'm going to draw my boundary lines. Now you can see your boundary lines, right? the difference between the two are 1 and -1, right? So this is a total distance of 2, so halfway, that would be 1 up and 1 down, so this is your midline, right? The y-axis, so y equals 0, so D is 0. And then here, from the midline to your minimum, or the midline to your maximum, right? It's 1, so that's what A is. So those are the two things you should find. We've got our cosine, right? So we picked a point. Then we're going to determine is there a phase shift? Well, I'm starting this curve not at 0, but over at pi over 4, right? So I've shifted to the right, by pi over 4. So that means C, right? What we're going to do is we're going to subtract pi over 4. So let's get started with this guy. Y equals, my amplitude is 1. Again, you don't have to write that. Cosine, because we're starting high. We have a phase shift. I'll come back to B right now in a second. This is theta minus pi over 4, right? Because we've moved to the right, so we're doing the opposite operation. Plus 0, you don't really need that. And now I gotta find B. So if I look, I start at my max for cosine, I come down, go back up, and then I finish my curve here. So this is my period. So my period goes from, my period is from 0, just kidding, pi over 4 to 9 pi over 4. So if you find the difference of those two, right, 9 pi over 4 minus 1 pi over 4, that's 8 pi over 4, which is really pi over 2. So B, to find B, we're going to do 2 pi over B equals pi over 2. And we've done this already, I think up here, but we cross multiply, right? We'll get 4 pi equals pi B. So the pi's cancel, and we get B is 4. So that will be my coefficient here. Leave it in factored form, and you can simplify if you want, right? Get rid of the 1 and the plus 0. So it's 4 theta minus pi over 4, and we have our cosine curve. Now you could also draw it from B, okay? So let's say we're at B, right? So if I'm thinking about B, this is a sine curve because I'm at the midline, okay? So I'm gonna steal the same, remember, we're not shifting or moving this graph at all, okay? We're just changing where it starts. So A, D, and B are all the same. So this is 1 or just sine, okay? 4, we'll figure out our C, and then plus 0, so we don't have to write that. Now, if you look, where did I start this? Well, they've kind of helped you out here. This is pi over 4, right? So each tick mark is a pi over 4. So pi over 4, 2 pi over 4, 3 pi over 4, and then this would be 4 pi over 4, which is really just pi. So then we're going to do minus 3 pi over 4. And that's our equation from point B. Either one of these will be correct answers. I will list both on the answer key. You don't have to do both. You only have to write an equation. So I will accept different answers, but I would expect to see that you're indicating where you started. So plot a point, label it A, or label it any way you want, but make sure I know where you're starting so that I know that your equation is correct. All right, now, these type of examples are where you have to give me both, okay? So I labeled points for you on here. This is A, this is B. So if we look at point A, right, that happens at pi and F5. So my upper boundary is at 5, my lower boundary is at 3. So where is my midline? Well, the difference between these two is 8, right? So if I divide that by 2, then that means this has to be 4 and 4, doesn't it? To get the middle line. So if I count down 1, 2, 3, 4, that will happen at y equals 1. It should kind of look like a road, okay? Where you have one lane and then the other lane, okay? This should be right in the middle. So that tells me that D is 1 and A is 4, because that's my amplitude, all right? Now, since this is starting high at a max, I know this is cosine. So I can start writing this equation as 4 cosine, right? I don't know anything else, but I do know I have a +1 on the end, all right? Then I take a look, do I have a phase shift? Because that's the next easiest thing to figure out. So if you look here, where did I start this graph? Well, I didn't start it at 0, so I've shifted it to the right. Don't always think it's going to shift to the right. Sometimes it might shift to the left, okay? So you could start it over here, but based on the picture they gave us, it's easier to use point A. So that's the one I chose for you guys. So this is shifted to the right pi, so I'm going to subtract pi, right? If I shifted to the left, I would just add pi. It's always the opposite. So this is minus pi, and then the last thing we have to do is find our b value. So if I look here, I start at A, I then come down, hit my minimum, and then come back up and hit a maximum, right? So my period here is from pi to 5 pi, isn't it? So therefore, my period, if I find the difference of those two, 4 pi minus 1 pi is 4 pi. Okay, so then we need to find b. So to find b, we're going to do 2 pi over b equals 4 pi. Then we'll cross multiply. So we'll have 2 pi equals 4 pi b, divide by 4 pi. So b is 1/2. Okay, so now we have our, oh, so here, sorry, I forgot to write. We got a phase shift, right? Of plus pi, right? So that's going to be a minus pi in our equation. Okay, so now I'm going to put the b in. That's 1/2. And then we just leave it like that. You do not have to distribute, okay? From b, you can see everything is going to stay the same. This is 4. But now I'm going to, for b, I'm going to use sine because we're at our midline. Okay, we're starting there. So this will be sine. Okay, 1/2 is the same because we haven't stretched or shrank this, so we have exactly the same. Okay, period. Then, if you look, have I shifted this? Well, sine should start, right, at 0, and it does. So this is just theta, and then plus 1. So the d is the same, the b is the same, and the a is the same, okay? It's just one has a phase shift, one does not. All right, last but not least. We have here, you guys have the point A, and then point B. Okay, so if I look at point A, all right, I do my boundary lines. Right, you can see that has a difference of, what, 6? So 3 up and 3 down, you can kind of hopefully see that the midline is y equals 0, so d is 0. And then the difference between your midline and your maximum, right, or your midline and your minimum is 3 units. So that means amplitude is 3, so A is 3. All right. Now, point A, right, which you don't choose, I've chosen it for you, that's a maximum. So I know this is going to be cosine. And if I look here, my next thing is, do I have a phase shift? Well, I don't, because I'm starting at 0. So that means there's no C value. So there's no phase shift for this guy. So C is 0, okay, for A. So I'm just going to write y equals 3 cosine, because again, we're starting at our max, we're gonna find our b in a minute, okay? There's no phase shift, so it's just theta. And then d is 0, so plus 0 is just 0. So now I gotta find my period, okay? So my period, I start at my point A. This is a cosine curve, so I'm gonna dip down to my minimum, come back to my maximum, and that happens at 4, doesn't it? So I have 0 to 4, so my period is 4 radians. Okay, so therefore, what is B? Well, we need to find B. I'm going to do 2 pi over B equals 4. Cross multiply. 2 pi equals 4B. Divide by 4. And B is pi over 2. So now, I pop that in for the B value, and I'm done. Okay, so D is 0. That's 3. Got no phase shift, we're good. Now let's look at point B. Now point B, I'm gonna use again the same A, B, and D, okay? Except, why do I have 2y equals? That's silly. Okay. Except I'm gonna change, because it looks like we have a phase shift here. So this is sine because we started our midline. So we're gonna do y equals, right? This is 3 sine, okay? I'm gonna use the same b, pi over 2. There's gonna be a phase shift, so I'm gonna leave that open, and then d is 0, so I'm just gonna, no plus 0. You don't have to worry about that. Now, when I look here, and it's kind of hard to say, but there's a 1. So I've moved this, started this sine curve over, right to the right 1. So that means I'm going to do theta minus 1 radian, okay? I know it looks a little bit weird, right, because it's not in terms of pi, but that's okay. So minus 1, right? And then the other thing you have to be careful of is, like we had on the other sheet, do you see how this is a sine curve? It starts at the midline. Usually sine increases, right? But now it's decreasing. So that means we have a reflection. So make sure you include that negative there, all right? So hopefully that helped. I wrote up in the notes all the steps that I followed for writing the equations. So if you want to use those while you're working on your homework, please look at my notes. But hopefully this all made sense. Please check your answers with my answer key posted to Schoology. And also, if you have a quick question and you're not sure about it, please take a picture, shoot me an email, and I can probably send you a quick video back to explain it to you if you're having trouble, okay? Hopefully you guys are doing well, and I will hopefully see you soon, and have a good rest of the day.